Instead of scrolling through static catalogs for hours, shoppers are beginning to interact directly with AI agents to find exactly what they need. The storefront is adapting in real time. A chat interface instantly reorganizes the digital showroom, generating a personalized product recommendation based on a single prompt. When a shopper asks for a couch that perfectly fits their specific living room dimensions and matches their existing decor, they expect an immediate, accurate answer. But while the front-end interface updates in milliseconds, the back-end supply chain supporting it remains constrained by decades of rigid architecture. Fulfilling that simple natural language request requires navigating discrete warehouse management systems, legacy enterprise resource planners, and isolated databases, all of which rely on manual query processing to synchronize. Attaching an advanced AI to the front of disjointed legacy software creates a massive architectural bottleneck. The system simply cannot fetch and organize the logistics data fast enough. To survive this shift, organizations must rebuild their enterprise data architecture from first principles, designing a foundation that natively supports autonomous back-end subagents. An intelligent storefront cannot function if it is tethered to a manual supply chain. The illusion of instant AI commerce requires a fully agentic operation behind the scenes. Consider the operational profile of a highly mature e-commerce organization, one operating in the top 0.1 percentile of supply chain sophistication. This operation relies on a complex, supplier-driven dropshipping model that spans North America and Europe, moving massive volumes of inventory without manufacturing a single item in-house. Logistics execution relies heavily on deeply entrenched warehouse management software. Core order processing, cancellations, and return data are simultaneously managed by a legacy enterprise resource planning system. This chart shows the traditional flow of information. Massive systems feed data linearly into a centralized query layer. The architecture relies on predefined connectors and manual approval gates. Data reaches a node, stops, and waits for human processing before moving to the next stage. Those manual checkpoints are incapable of making continuous, multivariable decisions. If you force thousands of microsecond AI requests through a system designed for scheduled batch processing, the architecture collapses under the strain. Legacy architectures act as a hard latency ceiling. They mathematically prevent true autonomous decision-making from occurring. An agentic backend operates on a strict mandate. It requires continuous, real-time decisioning across the entire enterprise. To achieve this, the architecture must maintain a maximum response time of 60 seconds from query to execution. Traditional data extraction pipelines fail this mandate. Moving data from an ERP to a warehouse and restructuring it introduces latency that breaks the AI speed. The structural solution is a zero-copy architecture. This establishes direct, simultaneous connections to legacy systems without duplicating any data. By accessing information where it already lives, there's no need to copy, move, or manually restructure databases. The extraction latency is wiped out. For components written in highly outdated custom languages, like older versions of PHP, artificial intelligence is utilized to rapidly re-engineer the code so it interfaces directly with this high-speed layer. On top of this real-time data flow sits the overarching intelligence layer, the Pi Agent Platform. Built natively on enterprise cloud infrastructure, this platform reads the zero-copy data and executes logical decisions. The enterprise bypasses the months of tedious database migration and data cleaning usually required for integration. Raw computing power cannot solve the speed problem if the AI has to wait for a database query to resolve. The architecture must grant instant access to the native data nodes. Moving from architectural theory to practical execution requires targeting a specific high-priority friction point within the supply chain. A standard target is reverse logistics, specifically aiming to reduce a massive product return rate of 10% down to 8%. Traditional returns are purely reactive. The enterprise waits for the item to ship, fail, and come back before a human physically inspects the damage and processes the refund. The first specialized AI node deployed onto the zero-copy architecture targets this specific process, the returns agent. Before a product ever leaves the warehouse, the returns agent executes a high-speed image analysis on the outbound package, identifying structural damage at the source. Simultaneously, it analyzes historical commerce and user behavior data to pinpoint serial returners and detect patterns of fraudulent activity. This capability is deployed rapidly by pushing pre-built agent code directly from a secure repository into the enterprise's existing cloud environment. Transforming a massive enterprise does not start with a universal overhaul. It begins by deploying one hyper-capable agent against a single measurable operational cost. But a returns agent operating in total isolation only solves half the equation. Commerce triggers a multivariable chain reaction. A sudden spike in damaged products being caught before shipment alters the actual available inventory. Completing the intelligence loop requires secondary nodes to join the network, specifically a planning agent and a logistics agent. The moment the returns agent detects a defective product run, it instantly routes that data laterally to the planning agent. The planning agent receives this feedback and autonomously recalculates demand forecasting, ensuring the enterprise does not overstock a poorly performing item. That calculation cascades to the logistics agent, which preemptively adjusts warehouse routing and reverse logistics capacity without waiting for a human manager to input the command. These specific micro-adjustments ripple simultaneously across the entire enterprise in under 60 seconds. An agentic supply chain is an interconnected, self-adjusting web of specialized sub-agents working together to maintain operational equilibrium. In this target end state, legacy software systems no longer operate as the command center for the enterprise. The deeply entrenched enterprise resource planners and warehouse management tools are demoted to a simple actuation layer. They exist only to execute the precise orders generated by the AI. The new operational core is a dense, orchestrated mesh of 50 to 100 interconnected subagents, calculating and executing real-time logistics decisions. The most significant barrier to achieving this state is not the technology itself, but the internal stakeholder delays and decision paralysis that plague large organizations. To counteract scope creep and enforce discipline, the implementation relies on a rigid, fixed-scope deployment model. A strict pilot timeline forces the integration to move from initial data discovery to a fully production-ready agent in exactly 4 weeks. Surviving the shift to agentic commerce is a matter of architectural rebuilding. Organizations must re-engineer the enterprise backbone to synchronize back-end fulfillment with the millisecond demands of the front-end